Hello, dear students. Hope you're doing well. We will continue our lesson, okay? If you remember what we have about the types of chemical reaction, we explained the first type of chemical reaction, which is synthesis reaction, and the second one, which is decomposition reaction. So the third one is about single displacement reaction, okay? Or sometimes we can use replacement reaction. This subject, single displacement reaction, you will have in grade 10, in grade 11, and also in grade 12. So it's important, okay? What is a definition of a single displacement reaction? Occur when one element replaces another element in a compound. So, why we call single? Because one element replaces another element. One element replaces another one element, okay, in the compound. For example, the general pattern of the single replacement reaction is like that. We have a compound, okay, a compound with one element. So it should be what? It should be element, one element, and plus a compound. You know what does mean compound? Compound. What is a compound? It means is made up of two, positive and negative, okay? For example, we have Ca and NaCl, okay? The compound with the element. So how you gonna recognize the single displacement reaction when you have one element, single element with a compound, okay? So, for example, our example is zinc when react with hydrochloric acid. Okay, this is HCl hydrochloric acid. So what we have? We have Zn, which is replace the hydrogen. Okay, look, Zn replace the hydrogen. So what happened? It becomes ZnCl2 and we remove this hydrogen. We remove this hydrogen because Zn replace it, so it become H2. And you know that why we write it H2? Because we have 7 elements that they are diatomic naturally, which is hydrogen, oxygen, nitrogen, chlorofluor, bromine. So because of that, we'll write it H2. Okay? So what we explained in this example, which is zinc replaced hydrogen, hydrochloric acid. Okay? Look, this is one element and this is a compound. So one element replace another element in the compound. That's a definition. Okay? So, sorry. Okay. So product is what? Hydrogen gas and zinc chloride. Okay? So, in single displacement reaction, a new compound form and different elements. That's right, we have element and compound. Now in the product also is element and compound, but it's different. Different compound and different element. And we know that product always is always different with the reactant, okay? So that was the single displacement reaction, okay? So then we should talk about what? Reactivity of the element. Why we talk about the reactivity of elements in single displacement reaction? Because this replacing is depend on reactivity. Okay? What does mean reactivity? It means how they strongly react, or are they react. So more reactive element can replace a less reactive element in a compound. What does that mean? More reactive can replace less reactive. Just imagine that more reactive, they have a lot of energy. Like just imagination. It's just imagination for your understanding, okay? More reactive element can replace less reactive. And for example, more reactive has a lot of the energy and less reactive has less of energy. So it can what? The more reactive, more energy can replace the less energy one, okay? Or there is another example. For example, in any place, okay, we always what we have in any place, we always have a leader, right? Then, for example, in our school, we have a leader, then we have teacher, then we have, for example, cleaner, okay? With respect for them. So, leader, it can replace with a teacher. It can be a teacher, right? But teacher cannot be a leader. Why? Because leader has more reactive and has more energy than the teacher. Do you understand? So the more reactive one can replace the less reactive one, but the less reactive element cannot replace the more reactive. Hope you understand well. Okay? Leader can be a teacher, but teacher cannot be a leader. Okay? So why teacher? Because of reactivity, because of the power, because of the energy. That those examples just for understanding. Okay, it's not related to the to those things. Only is depend on the reactivity. Okay, reactivity. So, for example, with example, always you will understand more. We say how you're gonna recognize the single displacement reaction. You have one element and a compound. So this is Cu and this is Ag. This is Cu, this is Ag. So this Cu wants to replace what? Ag, but in one condition. This Cu should has more activity than the Ag, which is silver. So in there, copper replace silver because copper is more reactive than silver. When copper more reactive than silver, it can replace. Okay? But reverse reaction not occur. Like for example, like that. If it is like that, Ag in there and Cu in the compound. What we have now, Ag can replace Cu? No. Why? Because Ag less reactive than the Cu. So for any replacing, the element that want to replace, it should has more reactivity. Okay? So why silver cannot replace the copper? Why? Because it is less reactive. So the importance, we have some important points, and it's mentioned in your book, which say group 1 metal. You know that in periodic table are most reactive metal. Group 1 or group 2, يعني generally the metal they are active reactive metals, especially group 1, which is most reactive metal. Maybe I bring it in blank, in true false, okay? Maybe I say group 2, so you should correct it to group 1. And very few non-metal participate in this reaction. Why? Because the non-metal are less reactive one. Only group 17 non-metal usually participate in single displacement reaction. Group 17 is what? Fluor, chlor, brom, and iod. Okay? So, the upper one has the largest reactivity. Then chlorine has less reactivity than fluorine, but more than the bromine. Okay, so fluorine can replace chlorine. Chlorine can replace bromine because why? Because chlorine more active than bromine, more reactive than bromine. Bromine because is more reactive than the iodine, so bromine can replace iodine. Okay, but iodine cannot replace bromine because iodine has less reactivity than bromine. So the less reactivity cannot replace the higher one. Okay? Bromine cannot replace chlorine. Chlorine cannot replace fluorine. Yani iodine cannot replace bromine, chlorine, fluorine. Why? Because it has a least reactivity. So, teacher, you mean that fluorine can replace all? Yes, because it has what? A largest reactivity in group 17. Do you understand? Okay, so the idea is what? The higher reactive element can replace, but the less reactive element cannot replace the higher one. Do you understand? Okay. That was the single replacement reaction. So hope you're doing well, okay? And understand it very well, please. For the homework, it's only write down the definition and one example. Try to bring it another example, not in side of your book, which is zinc and hydrochloric acid.